All right. Good morning, afternoon, evening to you, wherever you are. I am Paige Cruz, as mentioned. So delighted to talk about my favorite telemetry type and my favorite part of observability, which is distributed tracing. So to kick us off, I want to make sure I know what kind of tracing exposure we've got in the audience. So we will launch a poll question. My face when I think about tracing, fill in the blank. Are you unconvinced? You came because you want to see what this tracing thing's about, but you're not quite sure if it's right for you and your org. Are you tracing curious? Are you considering it? You've got an open mind and you're here to learn a bit more. Or are you a tracing fanatic? You love it, you use it, you came here to get the conversation started in your org and some good selling points to increase your adoption of tracing. We will let that poll sit for about a minute, but I just want to know a little bit of a temperature of the room of who we've got today. If you could not tell, I am firmly in the love it camp for tracing. I've been working with tracing for the past 6 years, so I could firmly say that I'm a love it. All right. And it looks like our poll closed. And I will check in on those results. Ooh, we've got a nice split here. We've got about 40% of folks love it. Those are my people. We've got 11 folks who are considering it. Hello to all of you. And to the 4 who are unconvinced, let's see how you feel at the end of this presentation. But I appreciate the candor. And we would not be talking to engineers and to technical folks if we did not have some skeptics in the crowd. So thank you very much for participating. Today, we're going to talk about chasing the single pane of glass, how that journey can be somewhat painful, and why you should go from monitoring entities or single domain services to monitoring the customer experience. And the spoiler alert is that we believe you can bridge that gap with distributed tracing today. And I'll share a little bit about how Chronosphere's philosophy around tracing is to enable developers within workflows that are familiar to them already so that the adoption is as seamless as possible. Then we'll hop into Chronosphere itself, and Joel, our product manager, will share some of my favorite features, including trace metrics, a topology map, and group by in the Explorer. And not to worry, if you've got questions, we'll do a recap and Q&A at the end. So this is our agenda for today. Let's dive in. Observability today. Back last year, Chronosphere launched the Cloud Native Observability Report. And we found some startling things serving engineers who were on call. One of the findings was that engineers spend about 25% of their time at work troubleshooting. For a 40-hour week, that's 10 hours a week trying to figure out where problems are, what's going on, who you need to talk to. And that can only go up the more hours your engineers work. This troubleshooting impacts your employees and the engineers by stressing them out. 54% said that they are frequently stressed out, and a stressed out on-call troubleshooter is not in their best frame of mind. That's not the state of mind we want our operators to be in. 45% of engineers reported that they don't have time to innovate, to push your business to new frontiers, to help your organization adapt to the dynamic environment of today. 45% say this troubleshooting takes up so much of their time, they're just keeping the lights on, spinning plates, keeping your business going as it is today, not able to take it into the future. And lastly, shockingly, 29% want to quit. And whether or not they quit, when you've got somebody that is that burnout and disengaged, again, not in their prime troubleshooting state of mind. So I mentioned this came from the Cloud Native Complexity Report. Well, how did we get here? And what is up with this single pane of glass thing? Well, It is supposed to be P-A-N-E, like a window pane, but this is what I think of when I hear single pane of glass. This is the image that comes to mind, because trying to understand your system using the paradigms and tooling of pre-cloud architectures of the monolith, I'm talking APM, application performance monitoring, using the perspectives and paradigms of that era for today, it breaks the single pane of glass model. Because when we were back in the monolithic world, it was great to have one view just of my application, and I maybe needed to care about a database. I maybe had a proxy that was sitting in front of it, but on the whole, I knew my service neighborhood. When I think of the single pane of glass today for our complex distributed systems across regions spanning the globe, I think it's unrealistic to expect one dashboard or one view to give you insights into everything you need. I've also seen these platforms, these legacy monitoring platforms, flex and try to be all of the things and try to be both the legacy world and the modern world. And what's wonderful is Chronosphere is here. I think we are third or fourth generation of observability. We are built, purpose-built for these complex systems. And without the contextual linking between your telemetry types, the humans have to work really, really hard to stitch together the story of what happened. And I think about it like this view. We're sitting in a car, that's your engineer, their single pane of glass is the windshield in front of them, and they've got the business asking them, why is there a pileup? Or why are you stopped? What's going wrong? And in an APM view, when you're looking at a singular service, you can see right ahead and you can see right behind. Again, traditional domain-centric monitoring, lovely for the architectures of yesteryear. Using APM today to troubleshoot these cloud-native systems, you've got a limited view. How is your engineer supposed to say, I'm stuck at a train crossing, or, oh, there was an accident up ahead and I better make a U-turn and shift my traffic elsewhere? From this vantage point, it's almost impossible to figure out the broader picture of what is going on. Enter tracing. Tracing is that traffic reporter in the sky in the helicopter who can zoom around, move around, see the whole picture, find hotspots where they are, zoom on in. Tracing was designed to help engineers understand complex dynamic systems, and the single pane of glass is now this dynamic, moving observatory field. And so we can answer not only where the pileup is, but we could also proactively start to see where hotspots are. And in this case, we've started to see that there's traffic piling up, but we don't quite know why. So we would want to enhance, and zoom in. And in this case, a unlucky lucky dog got loose on the LA freeways and was running around during mad traffic dash. Two kind Samaritans helped that doggy out. But if I was in that car, if I was an engineer in the car 30 cars back, I wouldn't have been able to see the dog or to see what was going on or understand. You needed that view from above that looked at the whole system and how everything was interplaying together. Proactivity. So what is the antidote to this? How do we get that helicopter view in the sky? Well, we think that it's distributed tracing. And if we think about that troubleshooting loop of figuring out whether we're in the car, figuring out why traffic is at a standstill, or it's your engineer figuring out why an endpoint has suddenly become slow, there's a troubleshooting loop that occurs. And we think of it in 3 phases. Know, so you are alerted, you become aware that there is a subpar experience going on. Triage, where's the issue? How bad is it? What's the impact? And then develop an understanding by stitching together and getting that full picture by talking across teams, across silos, to figure out what the heck is happening with your system. And to bring it home, I like to think about this example, which would happen to me a lot when I was an SRE. A metric threshold triggers an alert, and all of a sudden your on-call engineer sends a graph to the channel that says, hey, our error rate is spiking. We're looking at a graph that is charting the throughput or request rate for a particular service that is only broken out by our buckets of HTTP status codes. So our 200s, 400s, and 500s. So I can get some information from this screen. I can say, yep, I see at about 531, we started to see an uptick in 400s and 500s. But what questions would you have next? I would want to know, what service is this originating from? Is there an issue with a particular external third party? Maybe my third party is having an outage. Is it an internal dependency that is having failings? I want to know, was there a new version tag that got rolled out and maybe it's a bad deploy? This metric chart doesn't give me a lot of places to go from there. And to be clear, I love metrics. I know I said that tracing is my first true love, but metrics are not going anywhere. We need metrics to be that threshold to tell us when things are in warning mode and when they're in alerting mode. So traces and metrics, best friends. They are not competitive with each other. It's not a versus. We need both to understand our systems. But like I said, I get to this metric chart and I have so many more questions. And these questions I might not be able to answer. I may have to talk to engineers across teams. But let's take a look at this similar situation where we've been alerted to a high error rate. How could tracing have helped us? Well, our Chronosphere, we believe that taking a workflow first approach, that is not just slapping traces and saying, good luck figuring it out. We wanted to look at how do engineers today troubleshoot and meet them where they are so that we're not introducing a totally foreign paradigm or a new workflow. We want to embed in the workflow that your engineers use today. So what that looks like in practice, how do we do that zooming in out from the big picture view all the way down to the dog is stopping traffic? Well, first we alert, likely on a metric threshold, that something is okay, not okay, or we're missing data. From there, we get, of course, taken to the metric chart that is going to show us what triggered that threshold. But from there, this is where it's really key, going from those broad signals to specific. From that metric chart, we can ask those questions. What service is causing this? Is it downstream, internal, external? That is served by the topology view, service topology, service maps. There's a few names for it, but it is visualizing the nodes of a trace as the requests flow through, kind of like a real-time architecture diagram, if you will. So from there, you're able to quickly pinpoint where the hotspots are, where there's something interesting, where there's an elevated error rate. And from there, you can zoom in even more, all the way down to the request level and look at a trace waterfall and say, hey, maybe my hypothesis was wrong. There were no deploys in this time. Or, oh my gosh, every region is reporting errors, so it must not be an infrastructure issue. The great thing is, you can go all the way back out to looking at your metrics, looking at your topology, and continue to get this zoom in, zoom out, high fidelity, low fidelity signals from your system to understand what is going on. So, as mentioned, this is our helicopter in the sky view. This is a screenshot of our topology view, and you can see that we're just tracking the service requests. So the larger the bubble, the more requests are flowing through that system. Kind of looks like we're in that helicopter in the sky, and we can start to see what services are overloaded just with a visual look. Say we see something interesting, perhaps that demo track area. We can hover over that and get some more fine-grained info about request rate, errors, and our latency, or what are commonly referred to as the red metrics. That was pretty easy. Let's zoom in one more time to check out a specific trace. Well, this is what our trace waterfall looks like, and it's pretty clear from where I'm sitting where we've got our hotspots, and it looks like our spans that are tagged error equals true jump out at us right away, and we know, something with MySQL, something with Memcache. If I've got my telemetry tagged with the team owners, I can say, hey, I'm the front-end engineer, but I see that MySQL and Memcache are having issues. Send that trace over to the storage team, and away we go with our troubleshooting. So when we think back to the troubleshooting loop, before with metrics, it was a little bit of work to know, triage, and understand. In a tracing world, knowing becomes alerting on user behavior for critical behaviors like transferring funds, checking out, maybe a GDPR data request, want to make sure those are successful. And with tracing in place, you can have a seamless transition from that metric threshold that fires an alert. Perhaps it is an SLO-based alert. You can go from that metric view to looking at signals with contextual views, such as service topology. Who's calling me? Who am I calling? Where is the dependency chain breaking down? You can use that map to identify, again, where the issue are and coordinate across team boundaries. Instead of digging around in the storage team's dashboards and trying to get the data they would need, you can send one trace and have everybody looking at the same data to troubleshoot together. You get a lot more guidance from a trace on where the issue is than simply sending, oh no, our 500 rate's blowing up that metric chart. There's a big difference in jump starting somebody's investigation. Again, saving them that 10+ hours a week of toilsome troubleshooting. So you know that an issue's gone on because you've alerted off of your signal. You've looked at things in context. You've looked at your information and data in context with service topology, and you can gain an understanding by double-clicking into those interesting areas and testing out your hypothesis. Was it a node pool migration? Was it a rollout of a new OS patch? Was it app level? You can repeat this triage and understand because you're able to look at the macro view and the micro view and go back and forth all within Chronosphere. So it's not really one static single pane of glass, but more that you get to take the magnifying glass with you as you go. How do we power this? I'm glad you asked. My favorite open source project, OpenTelemetry. This is not the official tagline, but I do think it could be. Instrument once, observe anywhere. Chronosphere very passionately believes in open source instrumentation. The future of observability is open, and we are here for it. OpenTelemetry is a project that delivers high quality, ubiquitous, and portable telemetry so that folks can have effective observability data at their fingertips. All of the big vendors are on board, and many people are already running OpenTelemetry in production. If it's been a while since you've looked at the project or had an engineer do a spike on it, now is a good time to recheck it out. A lot has changed, and it is one of the top 2 most contributed to projects within the CNCF. So a very thriving ecosystem, more frameworks getting added every day. And very interestingly, they have the metric spec, which is, I believe, all good to go and frozen, and currently under progress is logging. Wouldn't it be lovely to be able to switch logging vendors at the drop of a hat? Keep up with OpenTelemetry, and that might be in your future. But I really think that the engineers at Equinix Metal put it best in their blog post, which I will link, leveraging OpenTelemetry to tune our Rails monolith. And they said, a tight feedback loop, granular traces, and the ability to query high cardinality data made it possible to quickly iterate and test improvements with some really great results. That is night and day difference from the 29% of engineers that are so frequently stressed out they want to quit. This is engineers at their best, enabling them with those quick feedback loops and getting a deeper understanding of their system. And this comes from both SREs and software engineers, SWEs. So I take their advice. They've got lots of very good blog posts about running the OpenTelemetry collector, and I'm happy to share that in the chat afterwards. So we've talked a little bit about the evolution of tracing, why tracing is key, how it helps your engineers, thus helping your business, giving them more time to innovate. Since tracing is still a new topic for folks, I want to pause right here and see, are there questions that we've got about OpenTelemetry, tracing, or any of the things that I've talked about so far? We'll take a quick pause for questions. And it is okay if there are not questions, because what is coming up next is very exciting, and it is our demo of Chronosphere. So I will double check the Q&A very quick. Nope. Lovely. Okay, everybody loves tracing, Joel. I think the crowd is ready to see what we can do with tracing inside of the Chronosphere platform. And I would love to introduce Joel, our PM of tracing, to show you our lovely platform.
Thanks, Paige. So we're going to do a quick switch over here, and I will share my screen. And a lot of what we're going to do is show you live in real time some of the static screenshots that Paige just walked you through. And I love the traffic analogy. It works as it relates to tracing. So we'll tie that in as we go a little bit as well. So what we're looking at on this page is a dashboard that a lot of engineers spend time monitoring a particular service or a particular part of their environment. In this particular case, you can see that we've created metrics from trace data. So one of the ways where traces and metrics, when combined together, are more powerful than used separately is when you use trace data to actually generate metrics. So what we're doing here is we're looking at an entire checkout process, and rather than trying to pinpoint the exact service, the exact operation where we may need to have telemetry being emitted, we can look at it in its entirety. So we can zoom out, get in the helicopter, and look at the entire traffic area by creating a metric that gives us a more end-to-end view of that entire checkout process. So what you have here, as Paige described earlier, are some red metrics about that checkout process. And you can see that requests are generally going up, but fairly steady. We have the same issue with errors, and our latency, the median latency, or P50, is pretty stable. But if we look at the tail latency, those P99 transactions, that there are some spikes there that might be an issue for us. And then down below, this is really our topology view that allows us to really zoom in and see what's going on. So again, we're looking at an end-to-end service of how a user in our example customer here would manage checking out. And this is all obviously invisible to them, but as an engineer, it's really important to understand the flow of the checkout process so that you can see everything that's going on. And as Paige showed, we can look at this from a service level. And right now we're using requests as our primary metric. And we can see that by the size of this particular node, that the ordering service is managing more requests than the rest of the service. But if I check in here and jump to errors, I can see that, and I'll do this back and forth a couple times so that it's clear to everybody. But there are a lot more errors as it relates to the total flow here in the portal service, especially as it relates to the total number of requests that are coming in through the portal service. And actually, I can see a pretty clear chain from the portal service to ordering service to billing service to this payment gateway out to an external third party. That shows me a lot of errors, and that's a troublesome spot that I might want to look for. Somewhere along that path, there is a dog running free on the freeway, and I need to figure out where that is. So latency spikes are an issue that we want to take a look at. And before we leave this topology view, just want to let you know that if I do care about this billing service, I can hover over it here. I can click into it and get a lot more details about what's going on, both in terms of raw numbers and as a percentage of the total. But let's go deeper. Now that we know that we have a problem on the freeway, let's try and figure out where our dog is. So I'm going to grab this spike on the duration P99 chart here, and that's going to allow me to just jump immediately into a page of the traces related to that spot on the graph. So as you can see, what we brought with us when we jumped from that page to this one is we brought this concept of the payment gateway service with us, and we also brought the time range. So based on where I clicked on this graph, which was sometime between 10:13 and 10:14, we're now zoomed in around 10:13 and 30 seconds. And we're using the close to operator, which means we're looking in front of it and behind it because we want to know everything that's happening around those things. And we are interested in errors, so we're only showing parts of this trace that are related to errors. So we can now scroll down here and look at a bunch of interesting statistics. So this is a statistical analysis of all of the traces that happened in and around that point on the graph where I clicked. So I can see based on, again, the same red metrics, requests, errors, and durations over here, interesting information. And ordering service seems to be of interest, but I also have a portal service here and other things that I might care about. So one of the things I want to do is I want to group this by something other than just the service and operation, which is the default view that I landed on. So by jumping in here, and I'll just type in service name, and now I'm going to group the same traces, the same statistical analysis, but I'm now grouping by service name. So I can look at them in their entirety and see grouped by service. And now it's pretty clear to me that portal service is something that I need to pay attention to. 100% of the traces that include the portal service in their transaction are generating errors. For any engineer, either a power user or a junior engineer, that's obviously going to be an area that you want to jump in and get some more details about. And coincidentally, probably not, the long tail durations are also worst with portal service. And in fact, my median duration, the length of the transactions to check out related to ordering service are also the longest. So I now have a hypothesis based on being able to zoom way out. And now I start to zoom in to figure out where the dog is and where the dog came from so that we can put the dog back in the truck where he or she belongs. And now I have a list of traces that are now, rather than randomly choosing an exemplar trace, which is kind of the needle in the haystack approach, I now have looked through a statistical analysis of all of the traces in and around that time period and pulled out all of the traces that match the criteria from my search. I'm going to quickly sort here by duration, and I'm going to pick the longest transaction through my checkout process. 2 seconds is a long time to go through that. So I now want to jump in, and we are into the trace that Paige showed you an example of before. And lo and behold, look at this, the ordering service here. I can look at the stats, error equals true. I know that I have a problem here, and I have some really important metadata about that service that can help me with my investigation. I know the build version of that particular ordering service, so I can jump in, I can add this to my trace search if I want, and a bunch of other really interesting information that now helps me zero in on the particular piece of information as part of the overall checkout service where it is. The last thing that I'll point out is you can see here the critical path in this dark blue version. These are all of the spans as part of the trace. So all of the pieces of work that make up the total checkout process that contribute to the overall latency. So that easily helps me understand where most of the time is being spent, and not just the overall time, but the time that is generated towards the total amount of that 2 seconds that we are trying to find and limit that. So with that, I will stop sharing and pass it back over to Paige so that we can take the next step.
All right. Thank you so much, Joel, for that tour of Chronosphere, of a snippet of our lovely tracing features within Chronosphere. I find new things to love about our platform every day, and I really do love just hopping right from, oh, I've got a question, right into querying for traces. So let's take a little bit of a recap. What have we covered today? What have we learned? And then we will turn it over for Q&A. From, again, that cloud native complexity report that Chronosphere put out. The other stat that really stood out to me was that 59% of engineers reported that half of the incident alerts that page a human, that interrupts their home life, trying to watch a movie, half of the alerts that they're getting from their current observability solution aren't actually helpful or usable, meaning they don't have the context they need, the engineer needs, to quickly run through, know, triage, understand. These engineers, that's where they're spending those 10 plus hours a week in toilsome troubleshooting. That's causing them to be stressed and anxious and burn out and want to quit. So my question to everybody is, what could your engineers do with not only those 10 plus hours a week back, but what could your engineers do and envision and create for you when they're not stressed from this stuff, when they are refreshed with their sleep, when they're excited about working on new value add and experimenting and innovating for the company? What could the next year look like for you if you were able to shift that? And I think tracing is the way. So we covered a little bit about why it is painful to chase that single pane of glass, that one dashboard, that one static view that can show you everything about the system you have today. It worked in the past. It's not working for us anymore, which is why the dynamic views with tracing to let you zoom in and out is one of the quickest ways for your engineers to troubleshoot, get a deeper understanding of their system, and get back to the innovation work you hired them for and that they're energized for. So with this, I would like to ask one more time to see if we have changed any minds, if we have turned any tracing skeptics into tracing curious. Please let me know right now your face when you think about tracing. Do you love it? Are you going to join? Will I see you at the OTel SIG meetings? Are you considering it? You want to spin up an OTel collector, maybe send some Chronosphere, some traces? Or are you like, I'm really excited that question and answer time is coming up because I have some questions for you. I am not sold yet. What camp you fall into? Let us know, and we will dive into asking and answering your questions about tracing, your questions about open telemetry, your questions about Chronosphere's awesome feature set with tracing, and the wide world of observability. Joel and I are very excited to chat with you today. So I believe we've got a few seconds left on that poll question. We will see if we've moved the needle. And hey, we've dropped down to only one person unconvinced. I'll take it. We've got 71% who are considering, and we got a few people who are loving it. I think we did pretty good today. So I would like to turn it over to Q&A. Let's pop this slide back.
Yeah, all right. Actually, we have some questions coming in. Let's take them from the top. The first question: what sort of the visibility would my organization get from a tracing metric that it doesn't get from a metric we generate on our own?
That's a great question. So the value of trace metrics versus just emitting the raw metrics yourself are, one, for if we looked at that HTTP the metric, is like HTTP request status code .4xx, .2xx, .5xx. You have to do a lot of that manual instrumentation to get the views that you want from that single metric. And that is where in other platforms, you're penalized for your high cardinality. That is adding maybe you're running load tests or you're running a large test suite and you'd want to trace for every single different test you ran. Well, thinking about adding test name to a typical metric in a different system, that is going to be a very, very expensive data set for you that your company probably won't want to pay for. When I look at metrics from traces, just from, so what we showed with the red metrics, your request rate, your error, and was it your request? Oh yeah, your throughput, your duration, and your error rate. Those all come for free off of what what OpenTelemetry observes for a single request. And a small nuance is you think, okay, well, if I'm sampling traces, doesn't that mean that those statistics or those metrics are incomplete? Are there holes in the data? To which, if you are sampling at the tail, which is you are letting all of your spans run through your system, you're letting your collector assemble the traces after the fact when we can make decisions about if it's interesting enough to save. At that point, we're looking at 100% of your spans. We're getting those metrics from 100% of the traffic that's running through. And so where you're instrumenting once for one trace or one span, you get all of these metrics versus having to have a really delineating out all of your metrics. And Joel, I'll let you, if you've got some other pro trace metrics tips.
Sure. I can just, I'll provide some simple examples that we see our customers using trace metrics problems to solve. N+1 is are issues that a lot of engineering orgs deal with, especially in a world where you have a lot of people touching the code. So we have customers who have very simple trace metrics where if the number of calls to a database exceeds, if the number of spans exceeds 10 or 20 or whatever the threshold they set, they want to be alerted on that. That means that there are inefficiencies in the way that that transaction is running and gives them kind of a guardrail by which that they can look at things. We have other customers that you could go in and manually instrument in your own environment, say your top 20 customers that you want to keep tabs on. It is much easier to create a trace metric because of the way it handles cardinality to monitor the top 20, let's say UUIDs that you care about most. And anytime we'll just use the same example, their checkout process exceeds 2 seconds, I want to be notified of that because these are high touch, white glove customers. And that allows me to do that. Again, something almost impossible to do with metrics alone. And then again, anything where you are looking across multiple services and you want to measure time or errors across a long part or a snippet of really high business value call flows and be able to add alerts and dashboards around those, really, really powerful use of trace metrics.
Agree. And I'll just wrap up and say yes, are you getting really, I wonder if the root of the question is, what is the value? If I already have my metrics, what is the value? You're telling me I'm going to get the same type of metrics from traces. What's the value in the re-instrumentation? And it's really the value add is, like Joel said, the relationship, the relationships between the components, between the nodes, between the services in your system, that the trace captures those causal relationships. That is the value add compared to metrics, and that ability to tie the traces and the metrics to go from, hey, there was a spike in errors, click, get to query all of the traces for that time. That jump from metric chart to traces that tell the story of what really happened for a particular request, that is the power that trace metrics unlock. Great question.
Okay, then the next question. Is it good fit for the real-time tracing to level for the kernel tracing? Like as an example, to find a specific process that blocking other threads to stop our workflow.
Yeah. Okay. So what I'm hearing in this question is almost like maybe if you're a performance engineer or you're really keen to optimize your service or a particular hot path in your system, is tracing a good use case for that? To which I say, yes, that waterfall view is one of the most powerful visualizations. I learned that we humans have what's called pre-attentive processing, and that is what we use when we take in visuals like charts and metrics and all of that stuff. So when we look at that trace waterfall, it is very easy for us humans to be like, oh, that looks like the n+1, or oh, I spent a lot of time in that cache. I wonder why. That's so strange. Let me look now at all the spans from that cache. So yes, when you're trying to do kind of that profiling level stuff or really understand where the slow spots are, tracing helps you get to the where, and then you can kind of zoom in and get your logs or more metrics or whatever more high fidelity signals after that. You can use that to inform, but tracing really helps you scope down where in this crazy call stack, where in this big complex distributed system, where is the issue originating, and then digging into the signals you know and love to answer the whys.
Okay, we have more questions. So next one, what are tracing requirements for the development team?
Great question. So it depends on how you have your operations, DevOps, infrastructure, cloud, SRE, platform, oh my gosh, whatever you want to call that team that works more on the internal platform. Depends on the responsibility levels that you have for them versus developers. But on the whole, what would a developer be on the hook for in this tracing world? Well, it would be using the OTel, the Open Telemetry SDK, the language or framework specific one. It's installing a library. There is a little bit of configuration for where you want to send your spans. Chronosphere collector works. Open Telemetry has a collector. You can kind of check those out. So for them, it's installing a library, learning the concepts of starting and stopping a span, and adding attributes. Really, the key for developers is for them to decorate these spans with, hey, this is what tier of customer made this request, or what region did this come from, or what is the team that owns it? Team ownership is a real good one to have, because, hey, if I see that Joel's service is blowing up, I want to send him a trace and let him get started on his investigation. But if there's no team owner tag attached to those spans for that service, I might be on a wild goose chase trying to figure out who owns this thing that is erroring. So devs are generally going to be in charge of that instrumentation layer. If you happen to have a mature SRE function, maybe they can help getting an internal library that bundles your logging libraries, your trace library, whatever you use for metrics. There's nice things you can do to pave the golden path, but on the whole, engineers should know how to emit trace data and then how to analyze it visually and make decisions on it.
Yeah, I will add one thing very quickly, and that is OTel in recent months has done a really nice job of up-leveling their auto instrumentation. So what you get out of the box is more useful than it was 6 months ago, just to be frank. So they're
Yes.
the community is invested in the spirit of this question, and I think that will only continue to improve over time.
Absolutely. Yeah, OTel moves fast, y'all. It is definitely worth, if you are curious about this, looking back through the end user working group about once a month for the Asia Pacific region and for North America, and I believe Europe. They hold meetings just to talk to end users and answer questions like, I have Kafka. How do I trace Kafka? Or I'm having trouble setting up this collector. It's a really great time for folks who are new to OTel or considering adopting it. It's a great place to soak up wisdom from other orgs that are further on their journey.
Okay, then I think this is the next question is also related to the open telemetry. So how much confidence my company should have that this is the de facto standard for trace?
Ooh, I mean, I have a million thoughts. Joel, I do want to let you go first. I'm curious how much confidence when you sit from your PM view of the world you've got.
From a Chronosphere perspective, we are all in on OTel. There is nothing else in the open source world that is even approaching the adoption and the momentum that OTel has today. So from a Chronosphere perspective, and I'll leave my comments focused on that, it's very high. We have high confidence that OTel, to the extent that if there ever was any rival standards, if you will, that has been settled, and the industry is adopting OTel pretty much across the board.
Yep. And I'll say, so I mentioned that I have been working with tracing since, oh my gosh, for like 5 or 6 years now, since 2018. My confidence in open telemetry is very high because I was there back in the day when we had the 2 competing standards Joel talked about. Google was putting out open census, a bunch of folks were hot on open tracing, and both were saying, we're the standard. Oh my gosh, we can't have 2 competing universal standards. And lucky for us, we found a way, the community found a way to merge those 2 projects, thus became open telemetry. And not only did we focus on it from a tracing perspective, but open telemetry also partners with Prometheus to make sure that there can be compatibility when we say a gauge or a counter, that we all mean the same thing. So for me, I look at the last 5 years, the long road it's taken to get open telemetry to be a thriving project, to looking at Equinix Metal, who runs it in production, to looking at Shopify, who runs the bleeding edge OTel Ruby SDKs. There are big companies that have already taken the plunge and maybe de-risked some of this for orgs that are a little bit more conservative. But all of the big vendors, the big observability vendors, came to the table and said, we will support OTel, we will take in this format, this is the future. And that is why Chronosphere, it was so happy to bank on the future of observability is open source. We would love to compete in a world where our observability platform is best in breed because of its features, not because we've got proprietary agents that lock you in. So yes, it is actively getting better month over month. It is still a new and evolving project, but it has the backing of all of the big players in a thriving open source community. So I think it is not as risky as it would have been to pitch it 3 years ago, let's say. Now is a great time.
One more question, and what is the advantages of using Chronosphere instead of using open telemetry directly?
So many. Well, we work at Chronosphere, so of course we're going to say, like, what is the advantages? Part of what makes Chronosphere special is our control plane, our visualizations in our UI, and the service map. When you're talking about just using open telemetry directly, it is the transport layer. I believe in the future they may look at to storage, but there's no UI for open telemetry. You can pull in Jaeger, which is an open source tracing UI, which is beautiful. But when we say open telemetry, it is really just the open source project focuses on sending data from your service, getting it to a collector so it can be stitched together into a trace, and then sending it off to an observability backend and UI. And so the advantages of using us are you get to see your data, and we've got some smarts as far as querying and ways to keep the storage costs down. And Joel, you definitely know more than I the many benefits of Chronosphere.
Sure. To start, 100% agree. It's a little bit of an apples and oranges comparison. We are 100% OTel compatible. So we are as big a fans as OTel as anyone. We use their data format for our users to emit spans in that format, and then we bring them in and store them and make them available to you to query. We are like others, we are a SaaS provider, so that you have the opportunity to have this available to you as a service and get all of the reliability and scalability and all of things that you need as your business grows, kind of built in. So stopping short of comparing us to other providers like us, I would say that we, like just about everybody in the industry, minus some of the more legacy APM vendors, are going to give you compatibility with open telemetry spans in that format. And then it's a matter of which service provider can you trust when you need them most, and scale to meet your needs and be able to help you manage the data in a way that you can ask questions and get the answers that you need when it matters.
Yeah, agree. Wonderful questions, though. I love this is a very good space to ask Joel and I all of the things you want to know about tracing. Why Chronosphere? Like I said, this is my third observability company, my second tracing platform, tracing enabled platform, and I chose it for all the reasons we described. I truly believe in OSS instrumentation. I have done too many migrations between monitoring vendors as an SRE. What a headache of a project. I really believe in this future of instrument once, observe anywhere, decorate as you go. It's an exciting future that we're all diving into, and I'm so happy that everybody joined us today to learn a little bit more about tracing, open telemetry, why you should consider Chronosphere. And I would like to just quickly plug coming up. Well, so monthly we're starting a live demo series. If you like to see behind the Chronosphere curtain, if you're considering it, come take a look next Wednesday at Reducing Observability Costs, a Path to Long-Term Control. And we will, in April, also be having a live tracing demo as well. So if you are hot on tracing, you want to see more, take a look at our events page. Keep an eye out for next month's webinar. And with that, Han, are there any other bits that we need to wrap up? Do we have time for another question if somebody's got a burning question?
Maybe we can, I think we still have the time for taking one though. So last question. In the demo, I didn't see any way to compare two sides of the data to see what has changed over time. Can I do that?
Oh, yeah.
Yes. Yeah. In the interest of time, we didn't go through all of the capabilities, but certainly one of the most important aspects of a tracing tool is being able to find what changed. A lot of people want to know, okay, now I am in a state that is bad. I want to look back a minute, a day, an hour, and understand when I was in a good state, what is different. And that's where the analysis of a lot of those metadata attributes comes into play. And we did not show that in today's live demo just for the sake of time, but yes, 100% that's available.
Okay, one more question coming in. Let's try to do this one as well. Do I need to have tracing deployed in every service for trace to be useful?
This is something I definitely hear a lot because we talk about the trace as valuable because it shows the end-to-end journey that your request ping-ponged between all the services in your system. And I say, yes, tracing is at its most powerful when it is end-to-end instrumented, but you don't get there overnight. And it is still useful to instrument one service and get that view of upstreams, downstreams, external, internal dependencies. It is still useful just for that one view, like it was useful when we all installed APM on our monoliths. It's still good to get a closer look at one component, but the idea is, oh gosh, one team finds this tracing stuff useful. They ask their clients to install tracing. They say, hey, I'm on the API gateway team. I know that all of my backend services call me. If you guys could add tracing, it would be super helpful because then we could start to troubleshoot faster. And so tracing adoption will be sort of that organic, you've got to go service by service. The auto instrumenting helps shortcuts things, but you can still get value from tracing even if you've just got a couple services instrumented. Don't let that be a barrier or let that stop you from starting your OTel journey today.
Okay, great. So unfortunately, I think that's all the time we have for questions today. So thank you everyone for being here with us for today's session. I'd like to remind everyone that the session was recorded. So following this webinar, you will receive an email with a link to access the recording on demand. And also I mentioned the qualified attendees will be able to get the pair of socks. So just keep eye on in your box. And we will send an email for you to really have the introduction and how you can claim your sock. And sorry, and I mentioned we recorded the session. So after the webinar, you will receive email with a link to access the recording on demand. And you can also visit our website events and webinar tab to find the recording and the more upcoming webinars and on-demand sessions. And any parting words or anything you'd like to the audience to know before we close out? Paige, Joe?
Yeah, I'd just like to say that today is the best day to start with tracing.